This question starts off quite wordy, but it's basically giving you a hint at the start. It's saying this will follow an exponential model. Then it wants you to take logs to try and create a straight line equation that you could then plot, and you can then make predictions about what P and Q are. So if I've got that y is equal to pq to the x, I can see from the answer that I want to take log to base 10. I'm just going to write log because that means base 10. Log y equals log pq to the x, and now I can use my rules of logs. So first thing, you can't bring this x down because p is not raised to the power x, so we need to separate them, use this rule of addition, log p plus log q to the x, and then we can bring it down because in the final answer we've got mx plus c x log q. I think I would then write it so it's directly in this form, so it's going to be log q x plus log p, and that is going to be my m, and this is going to be my c, and I've put it in the form as required. Okay, so then they've actually done this plot for us. They found log y of this value and they plotted against the x, and they've got what looks pretty much like a straight line. Estimate the value of p and q. So it wants us to use this straight line equation. It wants us to find the intercept, and it wants to find us to find the gradient. So you're going to need to draw a line of best fit through these points. That is pretty good, I'd say. So I'm going to get that the intercept is 2.12345, pretty much 2.6. C is approximately 2.6. I think I'll use the equal sign here. And that means that log of P is 2.6. And so P is going to be 10 to the power of 2.6. And I can work that out. It's 398.107. Sorry, 107. Okay, I think for this sort of question, how accurate can we be? Well, we've made, this is only a line of best fit by eye, so we can't be this accurate. I'd say we can work to two significant figures though, so this becomes 400. In the mark scheme, actually, it accepts answers between 300 and 400, so that seems to be on the upper boundary of what is accepted, but I didn't really feel like from the line of best fit that it would be less, so I think it could even be more, but that's what they say. Okay, let's now find the gradients. So I'm gonna start from, where should I start from? Let's go from the intercept and let's go all the way down to the bottom. That is good practice actually, to use the whole graph if you can. Okay, so I'm going from 0 to 8 along, and I'm at 2.6, and I go down to what I think I'm going to go with 1 there, so it's minus 1.6. So m is equal to minus 1.6 divided by 8, which is minus 0.2. As long as you're roughly again in this ballpark, that's fine. That means that log q is equal to minus 0.2. So q is equal to 10 to the power of minus 0.2, which is 0.6309, and I think we've got every right to round that to two significant figures, 0.63, and those are our answers for P and for Q. Use the model to predict when the number of missed appointments will fall below 20. So we've now got that y is equal to pq to the x. So I'm going to revert to using the full version, that's always good practice, times 0.6309 to the x. That's my exponential equation that I'm fitting to this data. Okay, so when is it going to be less than or below 20? Okay, we're interested in where it's less than 20. I could write the full thing out again, but I'm not going to. So it's going to be when 0.6309 to the x is less than, and then I need to do a division. Zero point 0.0502. I think you can get in some difficulty now. I think I'll talk about two things we could do. I'm going to take log to base 10 of both sides. Log to base 10 of 0. Sorry, that 10 is massive. Why did I do that? Log, it is to base 10, I just don't need to write it, is 0.6309 to the x, but I can bring the x down, is less than log of 0.0502. This thing is negative, so when I divide by it, I'm going to switch the inequality sign, and I'm going to work this out. Quite a fiddly question. Okay, and I'm going to get that x is greater than 6.493. So then we just need to look at the question. So we're only measuring appointments every week. We can see that, so it's going to be, we'd expect it to be after 7 weeks. Now, before I move on, I just want to quickly talk about one thing. It is possible to take log, you could have taken log to base 0.6309 of this thing. And the same to the right hand side. Oops, I'm running out of space. That is absolutely fine. However, okay, and then you'd have an x up here and you bring the x down, and then this technically would disappear. However, when you take log to the base of something that's less than 1, you have to also switch the sign around. So it was a less than, but it becomes greater than. I just wanted to talk about that very quickly because often like good practice is just to save a bit of time and take log of whatever this thing is, which is great. If it's 3 and if it's 4, you don't need to take log of base 10 and then divide. You can get there quicker, but if this thing is less than 1, you have to flip the sign around. It just won't work otherwise. You can see, like if you didn't keep the sign, you can see if you work through it that you would get you get the sign the other way around, so it must be switched. The last little part, you explain why the answer may not be reliable. Well, we've said, I think the answers kind of gives us a good indication about it. It says after 7 weeks. Now, our model only went up to 5 weeks. So what we are doing here is we are extrapolating, and that's the answer they're looking for 1 mark. This is still part of C. We have extrapolated. We do this all the time, but you have to be aware that it's not reliable. Why should it carry on in this exponential manner forever? It won't necessarily. This is not reliable. We can make predictions, we can look at it, but we just need to be aware that it might not be reliable yeah, as the question said. Okay, brilliant.